Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. If you remember last time, we said we are going to solve a system of linear equations, assuming or using the LU decomposition. We already, as I said, know how to solve that system using three different methods, either Gauss-Jordan elimination method, or the inverse matrix, when I invert matrix A and multiply it by the right-hand side, or by using determinants in Cramer's rule. So here we assume we have three equations in three unknowns. So I may have x1. I used some right-hand sides to end up with integer solutions. I mean, you don't have that. You don't need that, but to make life easier, right? Okay, so x1 plus 2x2 plus 3x3 equals 9. 4x1 plus 5x2 plus 6x3 equals 24. And finally, 3x1 plus x2 minus 2x3 equals 4. We are going to use that to solve for the system. So the first step we do, we say we're going to take our lower matrix and multiply it by a new variable that we call z. So z1, z2, z3 instead of x1, x2, x3. And let these equal the right-hand side, which is the b. Remember we said ax equals b. So we say this is b, or lowercase, it doesn't matter. Okay? Now, after we find the z's, we are going to take the upper, and we say if I multiply the upper by the unknown x's, I should get the z. So from here, I get the z's, and from there, I get the x's. And you say this is too lengthy. No, it's not lengthy. In fact, it is easy because that's a triangular matrix. So I can solve from the top down. And this is also a triangular matrix that I can solve from the bottom up, as you will see. So here is matrix L, 1, 0, 0, 4, 1, 0, and 3, 5/3, 1. If I multiply that by z1, z2, z3, which are artificial variables that I'm using, I will get 9, 24, and 4. I start from the top. So I get z1 equals 9. See, I didn't do anything. Then you move to the second row. You say 4 times 9, which is 36, plus z2 equals 24. Subtracting 36 from both sides, you get z2 is negative 12. And finally, 3 times 9 is 27. 5/3 of negative 12 is minus 12 over 3 is 4 times 5 is 20. So 7 plus z3 equals 4. So z3 must be negative 3. 7 minus 3 equals 4. See, it didn't take long. Now you move to the second part. You multiply the upper, which is 1, 2, 3, 0, negative 3, negative 6, 0, 0, negative 1 by the x's I'm looking for. And that should give me the z's, 9, negative 12, negative 3. Here, I start from the bottom up. Negative x3 is negative 3, so x3 is 3. No calculators, nothing. Then I move up. I say negative 3x2 minus 6 times 3, so minus 18, equals negative 12. You add 18 to both sides, so you get negative 3x2 equals 6. So x2 is negative 2. Then I move to the first, x1, which is unknown, plus 2x2, meaning minus 4, plus 3x3, meaning plus 9 equals 9. The 9 and the 9 cancel, and you get x1 equals 4. That's it. So I'm solving one variable at a time. 6 steps, 6 variables, I'm done. Okay? Let's take the other matrix that we did last time. And here I'm going to assume I have my equations are 6x1 plus 18x2 plus 3x3 equals 3. 2x1 plus 12x2 plus x3 equals 19. And 4x1 plus 15x3, x2, I'm sorry, plus 3x3 equals 0. And we want to solve for x1, x2, x3. Okay? So we are going to say L. I'm not going to rewrite L times Z. No, 1, 0, 0, 1/3, 1, 0, 2/3, 1/2, 1. I just don't want to make it a long session for you. Times Z1, Z2, Z3 equals the right-hand side, which is 3, 19, 0. Okay, you get from here Z1 is 3. Easy. And if Z1 is 3, 3 times 1/3 is 1, plus Z2 equals 19. So Z2 must be 18. 2/3 of 3 is 2. 1/2 of 18 is 9. Plus Z3 equals 0. Z3 plus 11 is 0, so Z3 equals -11. Okay? And finally, the last step, we are going to multiply the top 6, the upper matrix, 0, 6, 0, 0, 0, 1. In fact, here you see that one x3 and x2, you can find them right away without even substituting. -11. So x3 is -11. You see, here we don't even have x3. So you say 6x2 equals 18. You divide by 6, you get x2 equals 3. In the first equation, 6x1 plus 18 times 3, which is 54, minus 3 times 11, meaning minus 33, equals 0. Oh. Equals -11. Why did I say equals 0? I said, wait a second, something is wrong. Now, if you add, notice that these two guys is plus 21, right? Oh, I must have, wait a second. I think I did something wrong. 6x1 plus, why did I write? Yeah, it's 318 -11, correct. So here I get 6x2 equals 18, that's 3. Okay, so 6x1 plus 18 times 3 plus 3 times -11, which is -33, equals 3. Why did I say equals negative 11? It's the first equation, 6x1. Okay. So this is 21. When I move it to the right-hand side, they become negative. So meaning I subtract 21, I get 6x1 equals negative 18. So x1 is negative 3. So the answer is negative 3, positive 3, negative 11. I don't know what I was doing. Okay, now for the last thing, I mean, we are done, but just to check, we can use our calculator and use any method we want. So let me use, for example, Gauss-Jordan elimination method for the first one. I'm going to go to my matrices. This is already a 3 by 3. So I'm going to write 1. No, I'm going to make it 3 by 4, right? So I said I'm going to use the Gauss-Jordan. So I'm going to write here 1, 2, 3, 9. And then 4, 5, 6, 24. And then 3, 1, negative 2, 4. And then I'm going to go to math and select B, or you can, which is RREF. Oops, I'm sorry. This is just clear 4. So let me go back to RREF of matrix A. And you can see that x1 is 4, x2 is negative 2, x3 is 3. Here, I'm going to use a different method. So I'm going to go to matrices, select matrix B. It's a 3 by 3. And I'm going to enter 6, 18, 3, 2, 12, 1, 4, 15, 3. And then I'm going to create a new matrix. And I'm going to make it a 3 by 1 to enter the right-hand side. So 3 by 1, they are 3, 19, and 0. And now I'm going to invert matrix B. I called it matrix B and multiply it by matrix C. So we take matrix B inverse times matrix C. And let's see what we get. Negative 3, 3, negative 11. So it's correct. Okay, I thought I did something. I was like, got confused myself. So just making sure it's correct. And again, as usual, I think this completes the what I wanted to talk about in matrix factorization. And again, as usual, if you have any question or comment, don't hesitate to leave me a note in the comment section, and I will get back to you as soon as I can. Thank you very much. Next time, I was doing the eigenvalues and eigenvectors, and we use those to find some functions, some what looks like weird functions. There was one part I want to go over next time because I think that would clarify things when you end up with composite eigenvalues and what they mean, because they don't mean the same thing as real eigenvalues and eigenvectors. Okay, I'll see you soon, hopefully, and until then, be safe and have a good time. Thank you very much. Bye.